So we've done a lot with right triangles. Mainly we've looked at Pythagorean theorem. But what if I have a triangle where I don't have all three sides and one side missing, and there's nothing I can do for A, B, or C? For example, this triangle right here. I have 7 here, I have X here. There's nothing on this side of the triangle though. I can't do A squared plus B squared equals C squared because I'm missing one of those legs. I do have a degree. Can that help me? It can. So how do I find X when I have 2 sides and an angle? I use trig. So what is trigonometry? Trigonometry starts off looking at we're going to look at a basic triangle setup. We have our right triangle. It's always got to be a right triangle. And we have this angle measure, which is marked by theta. Theta is a Greek letter that just symbolizes a degree. Instead of putting a letter there, it's much easier just to put theta there. So we have our angle theta. Well, opposite our angle theta is our opposite side. Then adjacent means right next to, and that's right next to the theta. So that is our adjacent side. And then we have the hypotenuse. Remember, don't forget, the hypotenuse is always going to be opposite the right angle. So it's always going to be across from that right angle. The best thing for you to do whenever you come across a right triangle trig problem, mark your sides before anything else. So then we have 3 trig functions. We have sine, cosine, and tangent, but they are abbreviated when we're actually using them. So here we have sine. Sine is written S-I-N, and with that function is our degree. So this is where we would put our angle measure if we had it. So the sine of theta is equal to the opposite side over the hypotenuse. So we would put opposite over hypotenuse. When using sine, all we need are these 2 sides. We don't need anything on the adjacent side, and there won't be anything on the adjacent side if that's what we're using. Cosine, C-O-S. The cosine of theta is adjacent over hypotenuse. So in this case, we wouldn't have anything here. And then tangent is opposite over adjacent. So we would use tangent if we had something here and here, but not for the hypotenuse. So what if we took those 3 sides of the triangle, opposite, adjacent, hypotenuse, and we put them just as letters? O-A-H, opposite, adjacent, hypotenuse. And so here's my triangle again, but with only letters for each of those sides labeled. And when you label your triangle, you can just use the letters, that's fine. So now, sine is just opposite over hypotenuse. Cosine is adjacent over hypotenuse, A over H, and tangent is O over A, opposite over adjacent. If we were to take these, there's an easy way to remember what goes where when regarding trig functions. And that's where we get SOHCAHTOA. SOHCAHTOA. Let's look a little bit more at that. How did we get SOHCAHTOA from sine, cosine, tangent? SOHCAHTOA. The first letter in SOHCAHTOA, so we're going to break it into 3 parts. The first letter of each part is the function. So, S-O-H, that S stands for sine. The second part is SOHCAH, C-A-H, C stands for cosine, and then TOA, T stands for tangent. So sine, cosine, tangent. So then after that first letter, the second letter is what goes on top of that fraction, and the third letter is what goes on the bottom. So now you have 2 letters. Sine, O-H. Sine equals opposite over hypotenuse. Cosine, adjacent over hypotenuse. And tangent, opposite over adjacent. So break it down, SCT are the main letters that you need. And then if you don't remember what goes on top and what goes on bottom, write out SOHCAHTOA, then you can see sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. SOHCAHTOA, you're gonna need to remember that, and it's gonna be so helpful. Just keep it in your head.